Algebra 2 reviewing for our first semester final. We are now going to be graphing the quadratic. We want to write it in vertex form, state the vertex, axis of symmetry, and the y-intercept. So first off, if we have the function f of x is equal to negative 5x squared minus 10x plus 6, we first have to recall what the vertex form is. The vertex form is y equals a times x minus h squared plus k. This is f of x, no big deal, we just make it say y. Okay, then in order to get in this form, we have to complete the square. So we're first going to take any value that's attached to the x squared and pull it out of the parentheses. So in this case, we're going to take the negative 5 out, and we are left with x squared plus 2x. Leave a spot to complete the square in, and then your plus 6 still hangs out at the very end. So now we need to complete the square. So in this case, this value here is 2. So we're going to do 2 divided by 2 and square it. So this would be 1 squared, or 1. To keep the equation the same, we will subtract 1 and multiply it by negative 5. So then we are left with y equals negative 5 in parentheses x plus 1 squared. Negative 1 times negative 5 is a positive 5. 6 plus 5 is 11. So this is our vertex form. Now vertex form, it's very simple to see where our vertex is. It's just hk. So if we take a look, in here, our h and our k are right there. Recall that in the standard form here, it's a x minus h, so we have to take the opposite sign. So this would be a vertex at negative 111. Your axis of symmetry here is whatever your h value was, so x equals negative 1. And your y-intercept is when you are starting the equation, it is whatever value your c value is. So your y-intercept here is 6. You will also be able to get this information once you have it graphed. So here we're going to graph it. First off, we need to go to negative 1, positive 11. So I'm going to have to move this axis down in order to do that. So negative 1 and then up 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here's my vertex. Now the value in front here was a negative 5. So that means we think of our list of perfect squares here. 1 squared is 1, 2 squared is 4, 3 squared is 9. So if I go over 1, I normally would go up 1, except for this time I have to times it by negative 5. So I'm going to go over 1 and down 5. Over 1 and down 5. Okay, over 2 we normally go up 4, but I have to think about that I have to multiply it by negative 5, so I'd really go down 20. Over 2, down 20 is way off of our graph, so we're just going to have to use this information to graph it. And notice that our y-intercept here is indeed at 6. 1, 2, 3, 4, 5, 6, and that's what we said it was. We also are going to be graphing quadratics to help us solve inequalities. So to do that, we do the same exact thing where we get it in vertex form. So we'd have the x squared plus the 2x, then minus the 8. So here for vertex form, we'd add 1 and then subtract 1 at the end to keep it the same. So this would be x plus 1 squared minus 9 is greater than 0. So your vertex at this one is negative 1, negative 9. I'm going to have to move my axis up a little bit so I can fit this on the graph. So I'm at negative 1, negative 9 for my vertex. So 1, 2, 3, 4, 5, 6, 7, 8, 9. My number in front here is just 1, so I can just think of my perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9. So over 1, up 1 on both sides. Over 2, up 4 on both sides. And then over 3, up 9. And on both sides. And then I can go ahead and graph this. Right? It is just less than. So we're going to do dashed. And then thinking about where this graph would be shaded. You can view this as y is greater than, or the graph itself is less than 0. Either way you think of it, you get this area to be shaded. Focus on the x-axis, and right here is where your shaded region meets the x-axis, which happens to be from the point 1, 2, 3, negative 4 to the point positive 2. So your solution here would be from the point negative 4 to positive 2. And then last but not least here, we can solve the quadratic inequality algebraically. This involves us factoring. So if we have x squared minus 3x minus 4 is greater than or equal to 0, we need to factor this. We can do x and x minus 4 plus 1. If x minus 4 is 0, that gives us a solution of 4. If x plus 1 is 0, that gives a solution of negative 1. So we think about a number line. So we put negative 1 and 4 on the number line. We pick a value on each side of those as well as a value in the middle. So here we would have like 0, negative 2, 5. So now we have 3 values picked. We just need to check it with our original equation. So here we would take negative 2 squared minus 3 times negative 2 minus 4, and we're going to see if that is greater than or equal to 0. So this would be 9 plus 6 minus 4. 9 plus 6 is 15, minus 4 is 11. 11 is greater than or equal to 0, so we know that this section works. All right, when we plug in 0 here, we would get 0, 0, and just a minus 4. So negative 4 is greater than or equal to 0. That is not true, so we know that middle section does not work. And then when we plug in 5, we'd have 5 squared minus 3 times 5 minus 4. So 25 minus 15 minus 4, so that would be 10 minus 4, 6 is greater than or equal to 0. That does work. So we know that the sections to the left and to the right work. So what that means is here, the values from negative infinity to negative 1 work. And then we also work from 4 to infinity. So your ultimate solution here would say negative infinity to 1, and then pick up back at 4 to infinity.